So before we dive into the specifics of each extension, let's first discuss procedural syntax because much of it will be similar across all of the four extensions. So the structure we see here on the left is broken down into three distinct sections: the create header, the declaration header, and the execution section. The create header section is similar to how you might define a function or method in a programmatic language. You'll need to provide a name, the more specific the better, and you also define what parameters this function will receive. In this example on the right, we've defined a stored procedure that will receive an ID and an amount, and will reduce the amount from this user's balance. The create header is also where we would define what our function would return, but in this case, we won't be returning anything. Then we have the declaration header. This section is where we define our scoped variables. The variables must be typed, and we can't use reserved keywords, of course. And as we can see, we begin this section with the declare keyword, and in our example, we have three variables: balance table, which is a result set of this particular user's balance, and a balance variable, which converts that result set to a single scalar decimal value, and an updated balance variable, which subtracts the charge amount from the recently queried balance. Then lastly, we have the execution section, which basically holds all of the logical components and control flow of our function. The execution section is bookended with the begin and end keywords. In our example here, we have a simple if condition that checks if our current balance is greater than the requested amount, and if it is, we update that column with the updated balance. Here we have another example of a user-defined function, and in this case, we are simply executing logic and not running any SQL. And as we can see in this example, we've defined our function name, defined the parameter of n, and defined our return type of big int. We have no variables to declare for this particular example, so we can move directly to our execution section with begin. And here we see the basic algorithm for determining whether a number is a prime number. And we'll be diving deeper into this UDF in a later section. So now that we've seen a couple of examples, let's break down conditional flow. If statements work exactly like if statements in other languages, but instead of curly braces or indentations, we'll use the then keyword. Other than that, make sure to close off the conditional statement with an end if statement. Here we see two simple UDF examples. The one on the left is using an if statement to determine whether a given number is odd. And on the right, we have a series of if, else ifs to determine a letter grade for a test score. For while loops, we'll define our loop condition following the while keyword and capture the body of the loop between the loop and end loop statements. As always with while loops, just make sure your loop is not infinite and is always making forward progress. Now, for loops, of course, are great when you know exactly how many iterations are needed. These for loops might resemble most closely for in loops where a range is provided. The range can be an integer range from one number to another, or an array range where we are iterating through an array. Loops can be further customized by using the reverse keyword, which of course iterates in reverse, and you can also adjust your stride count by using the by keyword with a number, which of course iterates by that stride count. And lastly, some common commands that we'll be seeing for each of our procedural extensions. We can create, drop, show, and show create the functions and stored procedures we've created.